Okay, so let's take a look at page 2. I'm going to be real quick about this one. I think it's actually a much faster page than page 1. So first one was 12 minutes. This one should be a little shorter. So let's take a look and jump right in. I got class started in here in just a few minutes, and I'm hoping I can get a little done. So now this problem right here, when you look right off the top of the bat, it says, let's find all of the trig ratios from this angle right here, beta. So I mentioned in the previous video, or maybe you didn't watch that one, that we can sometimes just go ahead and reduce these. So notice these are both divisible by 4. So I'm going to go this way. Now, Pythagorean theorem would say that a squared plus b squared is c squared. So this is a 9 minus 1 is 8. So this guy is root 8, which I'm going to reduce to 2 root 2. So if we're going to go through and find all 6 ratios, we're going to find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent of all of those values. So I guess I'm going to go ahead and go with the easy ones first. I noticed that the sine right here is 1/3. Now I could have said 4/12, but that's the same thing. So there we go. I've got these two down. Hey guys, okay, just a little quiet, please. Okay, so now the cosine is adjacent over hypotenuse. So we're talking 2 roots of 2 over 3. Now, when I go ahead and I take its reciprocal, I unfortunately do get something that's a little bit, I get that extra root 2 in the bottom. So if I multiply the top by root 2 and the bottom by root 2, 2 roots of 2 times an extra root 2 is just root 4. Yeah, I was told that this gets blurry, and I think it's if it's not centered on the camera. So the tangent, of course, is 1 over 2 roots of 2, which makes the cotangent just 2 roots of 2 over 1. Now, if I multiply by root 2 here, I would get root 2 over 4, and that's it. So that's all of the 6 answers off of that question. Now, moving on to number 8, we have a couple of options. Now, this is not a unit circle thing. I don't have anything. I only have one side. So it's just going to good old-fashioned SOHCAHTOA trig. Notice the thing is sitting in degrees, so I'm going to make sure my calculator is in degree mode. So it is. And I'm going to just jump in here, and I'm going to take a look at the sine of 32 degrees. And the definition of sine is opposite over hypotenuse. So if I were to cross multiply, the z would be up here. Z sine 32 is 12. So that makes z 12 over the sine of 32. So that's going to be pretty fast and easy to do. 12 divided by the sine of 32 is going to be 22.645. 22.645. Now, not that it matters, but one thing that's interesting is if this had been a 30-degree angle, then this should be double. So if this was 30 degrees, there would be, remember the sine of 30 is a half, so this would be 24. So it makes sense that it got a little bit steeper. So it's not quite 24, it's a little bit different. Now, to get g, we have 2 options. We could either use the Pythagorean theorem, because now I have these 2 sides, or I could use a tangent. I personally go with the tangent, because if I made a mistake here on z, then I'd be using my error to produce another problem. So that's just my take. So the tangent TOA opposite over adjacent is there. Scoot that right underneath the camera. That's going to make g 12 divided by the tangent of 32. So 12 divided by the tangent of 32 is 19.204. Now, keep in mind, if you were taking a test, you would want to make sure that you're doing okay. So I would probably go ahead and say, well, let's try this. Let's take a squared plus b squared, and let's take the square root of that, and hopefully we're going to find ourselves getting back to that value for the hypotenuse, 22.645, and it did. So I didn't have to go that way, I just chose to go that way. Now, for number 9, one thing that's interesting is if you have 45 revolutions per minute, but you want to remember that a revolution is just another way of saying circumference. So every time a wheel goes all the way around, the tire should have moved forward exactly a full revolution, which is 2 pi r. also known as pi times the diameter, depending on how you like to look at it. Maybe if I go up a little higher, it's not quite as blurry. Okay, so the wheel is doing 45 of those, and it says the radius of the wheel is 20 centimeters. Okay, so there we go. So if the radius is 20 centimeters, that would be 90 pi centimeters. So 90 pi centimeters every revolution. Now, when you look at it, it says, how far did the vehicle go down the road in 6 minutes? So what I have is it's going to take this thing, let's see, 45 times 9 pi. Make sure I did that. That's 90 pi. That was silly. That was 90 pi. That would be very small. 90 pi. And missed something. 90 pi. So that's 12,723.45 centimeters. Well, that's silly. But that's centimeters every minute. Well, I mean, centa doesn't make sense. So let's go ahead and move this over by 2, because centimeters is 1/100th of a meter. So this would be 127.23 meters per minute. And so if I were to move that over by that 2, and then I'm going to go ahead and multiply by 6 because it says 6 minutes, that would either be 763.407 meters or 0.736 kilometers. Because remember, a kilometer is 1/1000th of a meter. There we go. All right, number 10, 26-inch diameter tire. So remember, pi times the diameter. So every revolution would be 26 pi inches. So we've got this bike going downhill at 20 miles an hour. This is kind of referenced to myself as a kid. I always knew that if I was going 20 miles an hour down a hill, I mean, it was always really fun, but if you got a bug in your eye, it was going to really suck. And my eyes would always start watering when I hit about 20 miles an hour. So if I did 20 miles per hour, let's see what happens. Let's figure out, I want to come all the way down to revolutions per minute. So I'd like to get rid of hours and go to minutes. I also want to get rid of miles. So I'm going to put miles here and go 5,280 feet. So those are dead. The hours are gone. And now I'm down to feet per minute. I'm going to get a little bit further. Let's get down to inches. Okay, so get rid of feet. Let's go to inches. There we go. So now I'm down to inches per minute, but I don't want inches per minute. I want revolutions per minute. So what I'm going to do is I want to make this thing 26 pi inches is a revolution. And if you look through all of the units, all that is left here is revolutions, and all that is left here is inches, and that's going to be my answer. So we got 20. We're going to multiply by 5,280. We're going to multiply that by 12. We're going to divide that by 60, and then we're going to divide that by 26. Just be really careful. We got to put that pi in parentheses. And so this tire is rotating at 256.56. 258.566 revolutions per minute, also known as RPMs. And I think that's where I'm going to end that video. Not quite all the way down to the bottom of page 2, but I think I'll hold off on graphing until the next one. See you guys back in class. All right. Bye-bye.